Hi, everyone. I'm actually just doing a very quick intro. So my name is Sarah. I am Director of Data Science for the Einstein platform. And I have two incredible teammates here with me, Natalie and Randy, who are developers on the Einstein Prediction Builder. And so today we're going to be covering really top to bottom what it means to build a prediction, how to understand your prediction, and then lastly, once you want to put your prediction into production, how you monitor it and understand, even extend it forward to analyzing when to really go live with it and change your business process. So with that, I'm going to turn it over to Natalie, who's actually going to cover an overview of Einstein's start.
Awesome. And we want to keep this pretty casual, so if you have questions at all during this, just shout them out and we can stop and talk through anything more in depth. So yeah, just to get started, we want to make sure all your purchasing decisions are based on stuff that's generally available today, which is less applicable now because we're just talking through how to use the tool, but always want to make sure that's out there. When we think of Einstein at Salesforce, it can be pretty confusing because so many different things come with the term Einstein. So to break it down, there's 3 different phases you can think about. The first one would be questions that a lot of different customers have expressed. That would be like the same industry in sales, let's say. Many customers want to know which leads should they focus on. So from that, we can create an individual product for that specific question. Although when we're doing this, although it's the same question, we want to be really clear, you're going to have a model that's individual for your data. Your data would never be used to create a model for a different company, and all the models that you use would never be influenced by data from a different company. The second phase then would be, let's say we have all these good products that can answer those questions. We aren't able to build out a product for every specific question that's out there. So the second phase then is becoming more customizable. We can empower you to say what questions are relevant to me and then build predictions based on those. When we're going through this, the industry in general has a lot of things that AI can be applied to, but the problem is it usually gets bottlenecked around data scientists. So we have the technology and the models and the data out there, but what does it mean to actually have a model running in production? You need someone to sit with it, really massage the data and get that model out there. But what's great for us is that trailblazers and admins can actually do a lot of that work on their own. So admins are really uniquely positioned because they have a huge, they know their use case super well. You know your business, and so you know what questions would need to be asked. You also know your data really well. So unlike a data scientist that would need to come in and try to understand where your data is coming from, how it's being used, you already have all of that knowledge. So really the only part you're missing is the technical model building, but that's where the Einstein tools can come in and really empower you to be that data scientist for your company and answer all the possible problems that you could come up with. So as we talk about those different phases, Einstein gets all the way into the platform services. This means as an admin, maybe you want to get really in-depth in the data science, and you can do that with different APIs we provide or using Einstein platform on that level. Transmogrify, I just want to do a quick shout out because I think this is really cool. It's an open source AutoML library that all of Einstein platform is powered by. This means you can go in and actually look at it on GitHub, see what automated feature engineering actually looks like. You can go through what does it mean to have model selection. If you're interested, all of this is out there available for you. But the good news is if you're less interested in this or don't want to do the coding part, you don't have to. So that's what's great about all the variety of Einstein tools that are out there is you can find something that works directly with the skill set you want to develop or what you are able to do today. Through all of these different products, though, we really want to stress that trusted AI is so important. So AI is an emerging technology, and we want to make sure that as we're learning how to use it, we're learning how to use it in the right way. This means really focusing on transparency. So even if you aren't really familiar with what it means to build a model, we still want you to understand what is in your model. Why are you getting the results that you're getting, and how do you know that you can trust them? Another aspect of that is responsibility. So making sure that the questions that you're asking are questions you want AI to solve. And there's a huge spectrum in what it means for an AI prediction. Like, what does that value mean to you? Maybe in some use cases it's great and you're just saying, I want to email this person when this is true. You don't need to worry as much about that. But if you're making a decision that really impacts an individual, you want to take a step back and say, maybe I want my prediction to just be influencing me, but still have a person making that decision at the end of the day. So AI is great and can really empower you with more information, but we want to be responsible in how we're using it. This is just a good visual of a lot of the different tools that I've kind of mentioned on the far, I guess it's right on the screen. No, left. Okay, so these are the phase 1 that we talked about. So that would just be, it's ready to go out the bag. That's a question that a lot of people have, and so we can have Einstein for Sales. That'll work with the general use case. On the far other side, those are the platform tools. So if you want to dive in, actually look at code, maybe experience some stuff with deep learning, that's great for you. Today we're going to be looking at that middle section. So that's the sweet part where you get to customize it completely. You get to define whatever your machine learning problem is, but you don't need to code it all. You can just use the Einstein Prediction Builder or some of these other tools to step through and make predictions just by clicking through some windows. And with that, we're going to have Randy walk us through what that actually looks like.
Cool, thank you. Thank you, Natalie. So I'm going to focus on Einstein Prediction Builder. It's one of the tools of many tools that we currently offer to do AI. And like Natalie was saying, it's an easy-to-use interface that is it's set up as a flow that allows you to define steps to create your prediction. So here, it's a declarative interface that's easy for admins, and it gives you fast results, and we will go through a demo here shortly on Einstein Prediction Builder. Okay, so really what kind of predictions can you create with Prediction Builder? There's 2 kinds you can currently create. We support numeric predictions and binary predictions. For numeric predictions, that is when you want to predict a number, so it's using the data set that you currently have to predict a number, whereas for binary predictions, it's going to use that historical information to answer a yes or no question. So, for a numeric prediction, some example questions would be like, how much is this house going to sell for, right? And then those scores returned would be a number. And of course, in the Bay Area, it's a big number. So for binary predictions, that's going to be a little different. This is going to be a yes or no kind of question that you're asking. And in this particular demo, we're going to ask whether the customer is going to pay late. So we're going to determine, if they're going to pay their invoice late. And some other examples are provided here, and the scores returned are really the likelihood for that to happen. So it's the likelihood whether this invoice is going to be paid on time. So we are going to pretend like we're a fictitious company and that we are providing internet services, and we want to know if the invoices are going to be paid on time. So with that said, say we have a custom object called invoice. We have some fields around the custom object, and then we also have a custom field that would be a binary, a checkbox field in this case, and then we want to run predictions based upon that checkbox field. So like I was just saying, we would want to target the invoices object. We are going to predict based on the late payment field, the checkbox field. We're not going to ignore anything, and we will use as examples for the prediction invoices paid on time and late. So with that said, let's go to the demo. Are there any questions up to this point? Okay, very well. Okay, so here we are already logged into Einstein Prediction Builder. We're logged into Salesforce, right? But we're on Einstein Prediction Builder. And this is what the screen looks like without any predictions. Looks pretty bare right now. When we go about to create a new prediction, all you do is select this button to create a new prediction. And we want to give our prediction a name. And we'll just call this, I have one hand, so forgive, no caps, prob paid on time. So if we were just going to name this prediction something that is something we can refer to later that's easy to understand. So we go next. Oh, shoot, wrong button there. Sorry about that. Let's see. Where are we, Sarah?
That's my map. It's white.
Okay. Oh, there we go. Okay. It's screens. All right. Thank you. Appreciate it. Okay, so now we're going to target an object, and as we saw before, it's the invoices custom object. We support standard and custom objects for Prediction Builder. So we see our invoice object. Okay, and here we could define global filters if we want to segment that information. So we could say, okay, let's kind of define the parameters for what information we want included in this prediction. And we could do that by targeting fields, operator, and a value. So if you want to do it by date, by whatever criteria is associated with that object, so whatever fields, right? And then we also have some logic conditions here. So you can say and or, and you can also define custom logic. So if you want to have mixed kind of logic conditions for how you want to set up those data segments, you can do that. We are not going to define any segments for this particular prediction, but just to validate, to know that we have records associated with this, we're going to run the data checker. The data checker will tell us, based on the criteria that you've already selected in the interface, how many records are available to us to validate if we're going to have a valid prediction. So that way you don't have to set it up and then wait for everything to be processed and then realize that it fails or it doesn't have enough data. So it's good reassurance. And also here on the right-hand side, you can see we have the prediction settings. So as we walk through, the prediction settings are going to show us how we set up our prediction. And here we're going to select the late payment checkbox field. So we could this is a type ahead, so we could select that if we want to, but we'll select pays late. And here, when it's a binary prediction, we need to define what the example records are going to be. So it tells us that we have to define some kind of criteria for that prediction. So here we're going to select the invoice status, as you saw in the previous slide, and we're going to say does not equal pending. So here, pending. And then we're also going to say that it's not null. So we want to add another row. So invoice status. And we say is null, is false. So we want to make sure that there are records that are not null. And of course, we could always apply the logic conditions as we saw in the segment filters as well. And here, if we want to find out if our prediction has enough data, we can run the data checker once again. And lo and behold, we have enough records to run our prediction. So you can also see in the the projector went out. That sucks. Check. Oh, cool. We're back. Okay, so as I was saying before, here on the right-hand side, we have the prediction field listed under the selected object. Okay, we got our field selected. We know that there are records. Oops, I jumped that screen. I'm sorry. So here are the fields that are included in the prediction. So in here, we're going to exclude the late fee from being included in the prediction. And this is kind of an important step, but it's probably better to opt on the side of including the fields initially, and then you can kind of tailor those as you get your scores back for your prediction. And here, what we want to do, I went to the screen first, that's why it's giving me a message. We want to define our PCF, or prediction custom field. And this is a special field that's flagged in Object Manager, and I'll show you that in a minute. This automatically creates a prediction custom field for us on the back end, and this allows us to have a field that's created for those scores to be pushed back. So here we're going to call it paid on time. And it autofills the field name. So we're going to say next. Oh my God. So what is the... There we go. Okay. All right. So here is our summary of our prediction. And we can see it has all the information that we just provided, the prediction name, the object, the fields, the included fields, and the prediction custom field name that we're going to save the scores to when they get pushed back. We're going to go ahead and build the prediction now. But first, it would be good to check your data now that everything has been set. Of course, I did that again. Sorry about that. But here are the numbers, so we know that this is going to return a good amount of data to run a prediction on. So I'm going to go ahead and build the prediction. My God, this is sensitive. Okay, done. And now we see our prediction ready to be built, listed in the view here. And it has the name, the field name that we're targeting, the checkbox field. And right now it does not have a scorecard and it's pending. But really quick, I want to show you the prediction custom field in Object Manager, just to show you where it lives and that it is an AI prediction field. So if we just toggle over to Object Manager, go to the invoice object. And we have probability, paid on time. Forgive me for only doing it with one hand, but you can see it here. And what it does is we create the prediction custom field based upon the checkbox field, the prediction checkbox field that you selected. And so we create this for you on the back end. You can also do this manually, but the important thing is that we actually set the field level security on this specifically for system administrators. So we want to make sure this is provisioned correctly, and that's why we do it with inside a prediction builder. So if you do this yourself, you may run into some issues, but using Prediction Builder to do it, you just make sure that everything is going to work for you. I'm not going to change anything here to make sure everything works, and that's pretty much it for my side of the demo. Thank you.
Okay, cool. So we're just going to jump over to this one. So we went through and actually had some predictions made, so we can go back and look and say, what does it look like when we return a model, and how can we figure out what this is saying? So as Randy mentioned, now that it's back, we see it's no longer impending, it's now ready for review. So we can jump in and look at the scorecard. Okay. Does anyone notice any comments from the screen? You want to just shout them out and we can go through and talk about them? So first of all, it says it's great. That's awesome. So I could just go and enable it right now, but that's just me blindly trusting whatever data science metric they push back.
How many data points are you querying?
It's a great question. I wish we showed that. But in the data assessor, which is what Randy said, it's not in this view, but if you went back, you could actually go through before you build the prediction and see how many you're going to base it on. So here, the number is really important. We also want to know what features the model is using. So not only how much data it had, but what did it do with that data? And over here we see that's what this top predictor is in. This tells us the features that are most important for the model. And this is just one overview, but if we really want to dive in, we can see a field level. These are all the fields that Einstein decided to use to produce this model. And then you can go in and see how many features it created based on that model. And if you go to the details page, this is all of that information on a spreadsheet layout. You could download the CSV if you want to send this off to someone to show them the work they've done. Maybe they're not an admin, so they can't see this page. So you can export it that way. But also just for us, we can go through and look at these fields and make sure they all make sense. You can sort them by correlation. You can sort them by impact. Correlation and weight are data science metrics. And I guess metrics is probably not the right word. But they're data science terms, and you can dive into that if you're interested on that side. Or you can look at impact, and that's kind of the absolute value of how important that feature was in a model. So we see here that autopay was pretty significant in determining if something was going to be paid on time. That makes sense. So if you have autopay set up, it makes sense that you would successfully pay on time. And if autopay is not set up, maybe that's an indicator of something else. What this means is autopay doesn't tell us too much that we don't already know. What we can do with that then is if we go and want to tweak this model later, maybe we want to get rid of autopay because we're not actually getting any more information out of that. What are some other things we can look at here? Name, that's a really interesting one. And actually, as I looked into this, name does not mean what you think it does. So if you were an admin, you might know that name is the API name for the invoice name. So this actually doesn't have to do with the person, whoever you're talking about. That being said, we also have these features, last name and first name. And those are interesting. So that means they aren't being used in our model, but we gave them as an option. And maybe that's something that we didn't want to do. Can anyone think of a reason you may not want to include name?
GDPR.
Yeah, exactly. So GDPR, that's like some personal information. Name can also be hashed, or it could be bucketized. And we can really sometimes tell your gender based on your name, or your race or ethnicity. So these are things where like maybe our model doesn't explicitly have those as fields, but that's something we want to know about our data, what fields include what information, so we can go through and exclude those next time around. So what do we do with that? We can go in and we can edit this model, go and change some things, make sure we're comfortable with first name and last name not being included. Or we could go and clone it and see, we want to keep this one so we can compare it to something that we've changed around. So we can keep playing with different things, tweak them, see what we like the results of best. Let's do it for clone. We can go through and separate out that autopay, just so we'll compare a model that has autopay with one that doesn't, and then maybe we want to push one into production but not the other. So we just call this predicted pay late version 2. We don't have to walk through all of this again, because I know you just did this with Randy, but here, this is where we could say, I only want to look at data that doesn't have autopay on. So we want to segment our data so this model only focuses where autopay is false. And maybe you want to build a different one that's like where autopay is true, and then you could find out some interesting things about whose credit card is going to stop working. But for right now, I think this makes sense for what we want to do. We can leave everything else pretty much the same, but then here, maybe we say we want to take first name and your last name out. And maybe we think email could also have some of that information in, so let's just take it out to be safe. And then everything else is pretty much the same. We're going to create a new field since this is a totally new model now, so we'll want to be pushing those scores back to a different model. So I won't walk you through the rest of it because it's all the same, but that's just one thing of like how to look at your model, and then you're not done there. Like that's where actually you can do a lot of critical thinking and use the knowledge that you have about your org and your data to look at that. And Sarah's going to walk you through some other ways that you can use that model result and really understand what's going on.
All right. Such great points, particularly on needing to evaluate the decisions and especially working with your business experts. Like data science is something where we're all learning together, and like Randy said in the beginning, we're setting this up and we're going through the stages, and we want to make sure to decide when we're going to make this field visible to all of our users so they can start consuming it. And so even as we're going through and we're building these predictions, there's always the question about what do we do next in terms of understanding in production what's actually happening with our models. So far what we've done is looked at how to set it up and the scorecard. But what we want to do next, actually, I'm just going to get out of this full screen mode because I moved it over. We'd love to actually look at what happens to our predictions once they're passed back. So let me just go ahead and take a look at our invoices list view here. So we have a bunch of our invoices and a few of the fields that have been kind of listed out. And what we see is that we have a bunch of our probabilities here that are, in all fairness, I didn't use the exact same the exact same language that everybody's using along the way, but it's probs pays late here. And really what we want to do is understand what has been pushed back. So just a few things of note from what we've seen so far. So you'll notice that there are a bunch that do not have any values for the probs paid late. So what you'll notice for starters is it's all of the ones that actually have paid on time late. So if you remember, the prediction exclusions is that we are using all of the records that have probs pays late, that already have invoice status as paid on time or as late, and we don't want to predict anything on those. We already know the answer because it's past the point of them having paid. So because of this, we use them as training examples, and we do not want to predict on them. What we also have, if you go a bit further down, actually let's just filter, is that all of the fields, invoice, this one hand thing is not trivial. So if we have invoice status is pending, we should expect to see only values again, but remember that if we actually add the auto pay, that this was the additional filter that Natalie actually reduced. And so you'll notice that we are not shipping predictions for any records that have auto pay, even if they are in pending status. So if we're thinking through the problem, this really has to do with all of the business points that have been made along the way. If I'm somebody who's trying to reach out to my customer to make sure that they pay on time, I probably want to make sure that my model is specific enough to not just say, hey, if you're auto pay, you're going to pay on time. That's not super useful. I probably want a separate model. And so the only ones that I really want to pay attention to are the actual customers that are in a pending state and have not yet paid and are not auto pay customers. So this is a great first start, but what I really hope is that everyone, as you're becoming citizen data scientists, that you take the mindset of trying to understand what it is that you would want to do next before making an assessment around whether or not you're ready to go with your model. So the evaluations that Natalie showed were on holdout data. And what you want to look at is over time, as these actual invoices are being paid either on time or late, how good is my prediction? So we have all of these probabilities and the invoice statuses that they're at when they're pending, but over time what's going to happen is we're actually going to end up with different statuses. Ooh, like the refresh. Live demo. So if we look down here, we do have a bunch of invoices that have predictions, but have now been paid over time. And so in fact, what we're doing is creating a report that allows us to see here, these are the various buckets for probabilities that we've shipped back on whether or not you pay late. And then the colors here are the different classes, which is at the end of the day, once they paid, did they pay on time or late? And so this histogram, which is just a count of how many records that ended up being paid either on time or late, had different prediction probabilities assigned to them, and which bucket they fell into. So all the dark blue truths you see tend to be higher up on the number, meaning that we're predicting with a higher probability they're more likely to pay late. And while there might still be some that we don't get right, it's a model, you should never trust a perfect model, that there are still things that you're missing. But in general, if you're setting up a business process, what you want to do is make sure that over time what you're observing is something like this. My model, as it's going forward and shipping predictions, is tending to tell me accurately that if I spend time on my higher probability records, if I sort them by probability, I'm likely to reach out to the right set of individuals. So if I have thousands of these invoices every month that I have to worry about, and I want to make sure that folks pay on time, I can reach out to those higher probability folks. Any questions? Yeah.
Yeah, so what you just showed was like testing the predicted against the actual. Is Einstein also doing this behind the scenes? Is it splitting like out some test set of data?
That's a great question. So everything that Natalie showed, if we go back to the scorecard, is actually precisely that. So when she went into the scorecard and she showed us these values, this is actually, it's a specific type of metric. I don't know if it's under the icon, but it's giving you an indication of essentially if you spend your time at the top end of your predictions, how accurate that would be. It's a very specific data science term that we've translated into a number. And it's being done at the time of training. If I think it was like 1,200 records, 1,500 actually, and I pulled out a subset of percentage of them. And so my model has never seen this data. And I build a model on the rest of it. And now I say, okay, on this data where I know the answer, but I didn't tell you, and I now test what happens. And that's the number that we're seeing here. So this is already pretty good in terms of giving you a sense of what's going on. Now, Natalie pointed out that inside of your details page here, there is this tricky concept of hindsight bias, which is while I didn't let the actual model see those extra sets of data that I held out, they were still in the end state, meaning they were already paid late or on time. And so there may be additional information that wouldn't be available for an unpaid or pending invoice. So if you remember, Randy held out the late fee field. Of course, a late fee is only applied to an invoice if you've already paid late. And so all of my hold-out data would also have this information. And if I use just, is there a late fee in my model, I will have a flawless model. But never trust a flawless model, because it probably means that there's an issue. And so this is the concept of hindsight bias. So while the transmogrify and AutoML work that we do tries to address this problem and fix it for you, it's always really important to spend time on your scorecard, to work with a business expert who really understands what all of these fields mean. Because I certainly, as a data scientist, when I spent time with my customers trying to help them build models, had absolutely no idea what fields meant. And similarly, most people setting up these predictions that are tech savvy just don't know the business side, and they're working with the business. So spending time in these scorecards to spot ones up front that might be problematic, like you're not okay. But then also going through and saying like, great, it's looking wonderful. Now let me actually look at, on the data set that I want to predict, where I don't know the answer yet, is there a chance that I'm not doing so well? And this is where those reports come in really handy, because they let you go in and look at the data and understand what's the difference, where am I not doing well. So if you're really excited about, at some point, digging further into the data science side of things, ordinarily what I would do in these situations is probably spend a little bit of time looking at some of the light blue ones that are further to the right, and the dark blue ones that are further to the left, to ask, is there something I missed? Is there something more I could do? So it's a very kind of let data speak for itself situation. Free it, give it a voice. Any more questions?
Question here.
So the models, do you based on the timeline of your model? Do you based on the timeline because the technology change? For example, you're talking about overpayment, right? So you can have invoice that back then 30 years ago, there's no overpayment, for example.
Ah, such fun problems. Brilliant. And I love that you're thinking about those things. So that can absolutely happen. The concept is known as data drift, where things change over time. So Natalie showed you how you can create some filters for auto pay, for example, in order to segment and create a separate model only on that subset of data. Again, if you work with your business and you have knowledge, or they provide you with that knowledge, you look at the scorecard and you're like, oh, I'm surprised this field isn't there. I thought it was going to be really predictive. And then you can ask things like, precisely that. Has this field changed in use? When did it change? And you can guide the model. Realistically, if it's a behavior that is long in the past and you have enough records that are more current, the AutoML will detect how to build a model, both with and without certain features, which are derived presences of certain values. But if you can help the model along by saying, like, let's build a filter if something is, too old, go ahead and do that. It can really, anything you do to refine your model in that way will always help it along. Is that helpful? The old adage, garbage in, garbage out. The cleaner your data, the better it is. Wonderful. So we wanted to make sure that everyone gets fed. So with that, just a wrap-up slide. Today, Natalie covered this. We showed the Einstein Prediction Builder. And we touched a little bit on the AutoML that's underneath it. We do have these new Einstein platform services for developers that have been announced. There's some cool blogs out there, a Salesforce blog on it, and some other stuff you can read. And I hope in the future the folks that have built that on our team are also going to come here and share with you around those Einstein prediction services and how you can use those. Thank you so much for your time.